All right, let's start with our exercise 8. Now, this is an interesting example. Now, an array or a matrix is given. So this is the array or this is the matrix. Here the input can be an array or a matrix, and we have to perform these tasks. So let's see what is the first one. Create a list of all the even elements in the matrix. So if I have an array like this, I have to find out only the elements that are even, not the odd elements. I have to take out the even elements of the matrix. So 213, that's an odd element. So I will not take this. 209 odd. So again out. 310, this is a even element. So I will put it here. So in this matrix, so I have to create an array like this and put everything in that array. Okay, so this is our task. So let's start with our A. Let's copy our A. Place it here. Okay, so this is our A, and it has total 25 elements. Now, how to actually check whether the element is whether the element is an even element or an odd element. So let's try it here. So this is our exercise 8. Exercise 8. Now, say for example, if I try a is equals to 8, let's see, a is equals to 9, not 8, make it b. Now, how to check whether an element is a odd element or an even element? So if, for example, if I have something like, say for example, 5, okay, 5, if I divide it by 2, I will have a 1 will be the remainder. But if I have something like 6 and if I divide it by 2, the remainder is actually 0. Understand? Remainder, not the division value, divided value. So the division value is like 2.5 or something like that. That is not what I'm interested in. I'm interested in what is the remainder. So remainder is 1. If it is even, the remainder is 0. So I want to do this remainder. Okay. To find out the remainder, there is a built-in function again. So we can do these things. So the built-in function that is called, okay, mod. Okay, always keep a look at what are the built-in functions that I'm adding here. So this is a mod function. Let's see if I can write it. So say b is equals to our 9. Okay, so if I do mod of b, it takes two elements. So I want to check if b is divisible by 2 or not. If I do this, so I return, it actually returns 1. Again, let's see if b is divisible by 3. Now it returns 0, because if I divide 9 by 3, it is divisible, so 0. So if multiple by say 5, now it returns 4, because if I divide 9 by 5, I'll get 1.8. So the remainder will be 4. So mod actually provides the remainder. Okay, remember that. So when we are actually trying to our question, we are trying to find whether this element is divisible by 2 or not. Okay, so we can simply say if this one, if I divide a by this 2, if I have a remainder of 1, that means this is a odd number. If I have a remainder of 0, okay, then that is a even number. Okay, I hope it is clear. I believe it should be clear. Now we can actually again we can actually write a for loop starting from the first element to the 25th element, then check each of the element whether it is actually divisible by 2 or not. Okay, something like that. But we are not going to do it. So what we are going to do, so this is our a. What we are going to do is modulus of a comma 2 is equals to 0. So what it is doing, it will automatically take all the elements one by one. So modulus of a comma 2, and it will check whether that division is 0 or not. So if I do it, as you can see, so first element was 213. The modulus of 213 and 2 is 0. Okay, is not 0. Okay, so that means it is false. So that's why it is giving me false. Okay, then 209, it is again giving me false. When 310, it is actually divisible by 2. So that is why it is giving me 1. 1 means actually true. Understand? This is a logical array. It is providing whether this statement is true or false. That's also the purpose of logical array. That is not the that's not the remainder value. This is the original value. So now I have this value. So I have this output array, and now what I want to do, I want to just bring out the elements that have 1. Okay, so we can actually again we can go through one by one and just bring up those things, but we are not going to do that. There is much more efficient way to do this. Let's take a look. So our task 1 is equals to something like modulus of a comma 2 is equals to 0. This was our statement. This will actually give me this logical array. But now I want to bring out the elements that are 1. I can just simply write something like this. Okay. Let's see if it actually works or not. Let's run it. And it is actually providing me this output. So what it actually is doing. So let's try to explain this thing. Okay. So this is another example of vectorization, and vectorization is so much powerful that I don't want to write for loops because it will only be unnecessary for you. So let's say our elements is 3, 4, 6, 7. So 4 elements. So what we are trying to do, each step we are trying to write this one. Okay, modulus of x comma 2 is equals to 0. So this is our statement. I am trying to check whether this element modulus of 2 is equals to 0, whether it is 0 or not. Is it 0? No, it is not, because the modulus will be 1. So the output will be a false. Okay, this false f. So when actually MATLAB actually doesn't write this f, it actually provides 0 for it. Okay, this is a logical 0, not it is actually a logical 0, not the integer 0. We can check it. Let's do something. Let's do something like this. Y is equals to, if I write class of y of 1, you can see this 0. So I'm just trying to find out the class of this 0. This is a logical 0, not an integer 0. Okay, this is a logical array. I hope it is clear. So let's go back here again. So what we are trying to do is 3 modulo 2 is equals to is actually false. Then again 4 modulo 2, that is actually 0. So it is actually returning a true or 1. Then again 6, it is returning an 1. Then again it is returning a 0. So then what we actually did is I am taking this array. So I am taking this array. So this is my output array, and I am saying, okay, give me, sorry, I was using x, right? So give me x of this, give me x of this. So what it will does that, so it will give this element, it will actually match this element. When I have a 0, that means false, it will not return that element when that is false. It will only return those elements that has a 1. So when it sees that I have something 1, okay, return the value of, so return, this is our original x, this is our original x. So this 3 has a replica of 0, so it will not return that is false. It will only return that is true. So it will return this 4 and it will return this 6. Okay, so this is actually the more advanced way to write a vectorized code. So if it is not clear, okay, we can actually review these things again in the review class. You can ask the question there if you don't understand something. So if you just try to work with this a little bit by yourself, you will see this will actually start to make more sense. Okay, and let's actually go there again. So this is our code, and so it is actually working. It is actually working properly. Now, what about the other one? If we come here, our input can also be a matrix. So let's do this for matrix as well. If we see here, so let's paste it here. So this is our matrix, and we want to work it for matrix as well. So T1 of 2 is equals to, copy and paste it. Instead of A, now our input is B. Let's see whether it works or not. So as you can see, this is what you want to, and 26, then 144. If you check the output, and that is actually providing the correct output. So it is also working for our matrix as well, because what we did here is modulus of b comma 2 is equals to 0. It is actually providing this array. Then I am taking only the values that are actually 1. That's why it is providing me all the values as a column vector. Okay. So I hope it is clear. Now the next question is find the index of the linear index of all the even elements, even numbers. So we are asked to find the index as well. So here in these 2 lines of code, we have seen what are the values. Now we are asked to find the index. So you know how to do about it, I believe. So T2 is equals to find, if you remember. So find this. Okay, modulus of a comma 2 equals to 0. Find this. Again for T2, copy it. T2 of 2 for the matrix, I have to find the index of those things. Okay, let's try to run it. So I don't need them anymore. So let's just replace those things and run it. So it is also giving me this 378. If it 3, 7, 8, 9, 10, then again 1, 2, 3, 4, 5, 6. So all of them are correct. So this is actually providing me the correct answer. It is only giving me find this, and find will actually look for those elements that are actually true and give me the index. And this is the linear index. Okay. Now let's see what is the last question. Find the subscripts of all the even numbers. So this is asking for the subscripts. Now, if you remember in our previous, there is something like this. Index to subscripts. I have already a function that I have already showed you in your one of the previous labs. So we can use this function to actually perform this third task, find the subscripts. Okay, and I showed you how to do that. So I'm not going to repeat it here. Just go to the video if you don't remember and watch it again. I believe it should be okay. Okay, so I believe that is clear. And there are some additional questions. Try for odd numbers. Solve this same problem for it is for even numbers. Try for odd numbers. The numbers divisible by 3. Let's add something. The number divisible by, let's say, 11. Okay, let's add something. Okay, so this is our exercise 8. Now let's take a look at exercise 9. Now in exercise 9, it is a small exercise. Okay, an array is given and perform the following task. So this is our array. Okay, this is our array. Now let's just clear this one. This is our array. Okay, so we have been asked to perform this one. Sort the array in the descending order, then ascending order, then find the unique elements. Let's do this. Now, if you're actually familiar with sort, if you are actually familiar with other programming languages like C programming or Python or C++, you have probably heard of different types of sorting algorithms, I believe. So, for example, there was insertion sort. Okay, then there was bubble sort. Then there was quick sort. Okay, then merge sort. These are different sorting algorithms that you have actually studied, I believe. If you haven't studied those things, don't worry about it and don't feel like inferiority complex. Inferiority complex. Don't suffer from these things. Okay. What we are actually trying to do here. So when we actually perform the sort in MATLAB, we'll actually implement this function, this quick sort. Okay, MATLAB automatically performs this quick sort. Okay, we don't need to write all of those in details of these things. It will automatically perform the sorting task. So let's take a look. If I like something like sort of A, it will automatically sort this array for us. So 2, then 2, then 2, then 4, 4. So it is going through the ascending order. Okay, so by default, this sort function automatically sort an array in an ascending order, and this sort is actually a quick sort. Okay, you don't have to worry about the other types of sort, that is the time complexity and so on. You don't have to worry about it in MATLAB because quick sort is one of the fastest sorting algorithm. Now another thing is that the second question actually said something like that: sort the array in descending also. This is what we actually done. Ascending order, we have done the second task. Let's take a look at the first task. Sort the array in descending order. How can we do that? Again, I know, but if you want to know how to do that, you can always go to the sort and try to look how to do it. Okay, this is actually the best practice. So you can see the direction here, something like that. What does it say? If I want to change the direct, I have to add this one, this descent. Okay, so if I write here something like sort A, comma, descent. Okay, so it will automatically sort it in the descending order. Okay, this is the largest element to the minimum element, so that's why it can do it. So in third question was find the unique elements of the array. So I have already introduced you to the unique of A. Will give you the unique elements. So these are the unique elements without any kind of scriptation. But one thing to look at here is that when you are performing the unique operation, it is actually doing the sorting automatically. By default, it sorts the array. Okay, and that was the fourth question, that find the unique elements of the array, keep the sequence unchanged. I want to keep the sequence unchanged. That means 2 came first, then 2, but 12 came second. So it should actually hold this position. So what we can do, again, if you want, you can just go to here. I'm just writing it here. unique comma a. Now what I'm going to do is write something here that is called, I forgot the name, so let's take a look. I actually forgot the name. Unique. Okay, so here stable. Okay, so if you write here something that is called stable, okay, if I write it here, so if you can forget, okay, you don't have to memorize all of those things that is inside. You can just use the documentation anytime and actually learn those things by yourself. So just remember, you have to remember this one, the unique function there. So if you want, you don't have to remember whatever that is inside. You can actually search it in the documentation page. So if I write this code, sorry, I did something. So this is now actually sorted. Sorry, it is actually providing the unique elements, but not sorted, unsorted way. So I hope it is clear. Just try to practice it a little bit by yourself, and I think everything will be okay. Okay, so let's finish it here.